How is a digital signal created from analog input? Imagine trying to capture the sound of a bird singing or the flickering of a candle flame. These are examples of analog signals, which are smooth and continuous. But computers and digital devices work with numbers, zeros and ones. So, how do we turn these smooth signals into something a computer can understand? That's where analog to digital conversion comes in. It's a process that transforms real-world signals into digital data that can be stored, processed, or transmitted. First, the analog signal is sampled. Think of it like taking snapshots of the signal at specific moments in time. The rate at which these snapshots are taken is called the sampling frequency. If you don't sample fast enough, you risk losing important details or creating distortions called aliasing. According to the Nyquist-Shannon sampling theorem, the sampling frequency should be at least twice the highest frequency present in the signal. This ensures the digital version accurately represents the original. Next, each of these snapshots, which can have an infinite range of values, is approximated to the nearest value within a set of fixed levels. This step is called quantization. The number of levels depends on the resolution of the analog to digital converter. For example, an 8-bit converter can representing to 156 different levels. This step introduces a small error called quantization noise, because the original amplitude might not match the exact level it's assigned to. Finally, these quantized levels are converted into binary code, a series of zeros and ones. This binary data is what makes up the digital signal. The process involves encoding each level into a specific pattern of bits, which can then be processed by digital systems like microcontrollers or digital signal processors. To make sure the sampling is accurate, a track handhold circuit is often used. It captures the analog voltage and holds it steady during the conversion process, preventing errors caused by rapid changes. The resolution of the converter determines how detailed the digital representation is. Higher resolution means more bits and more levels, which results in a more precise digital signal. But it also requires more processing power and memory. Choosing the right sampling rate is also important. Sampling too slowly causes aliasing, while sampling too fast can make the system more complex and generate larger amounts of data. Quantization noise limits how accurately the digital signal can reflect the original analog input. It affects the overall quality and fidelity of the digital output. In real-world applications, analog to digital converters are used everywhere. From capturing audio in microphones and digital cameras to measuring sensor data in embedded systems and communication devices. They are essential for turning signals from the physical world into digital data that computers can handle. In summary, a digital signal is created from an analog input by first sampling the continuous signal at specific times, then approximating the sampled amplitudes into discrete levels, and finally encoding these levels into binary code. This process allows real-world signals to be processed, stored, and transmitted digitally.